My name is Dr. Ashish Dixit. So today we will discuss about the red black tree. Okay, red black tree is a topic that's also work under the design analysis of algorithm. So here we will discuss about the two topic of the red black trees. So here I also divided red black tree part 1 and red black part 2. In a red black tree part 1, we will discuss about the properties of the red black tree, rotation of the red black tree and insertion in a red black tree with fix up cases. Okay, so let's start. So here we will discuss about the red black tree or the variation of the binary search tree to ensure that the tree is balanced, because it's also considered the concept of the binary search tree. And how it will be balanced? It's totally work on the behalf of BST. Okay. Then the height of the tree is log n. Okay. The height of the tree is a log n, and if it's had the number of n nodes, so it will be considered in a big O log n. And operation we will take a running time big O log n in the time of the worst case. So here a binary search tree plus 1 bit per node attributes. It's also have attributes like a color. Maybe color will be red or a black, because it's totally depend on the name of the red black tree. That's why here some node is related to red and color and some nodes are related to a black color. Okay. So here we will also discuss about the BST inherited concept, key, left, right and parent node. Okay. So all the empty tree leaves, you know very well, if a node, then in a last node we have some leaf. These leaf have the value of the nil. Okay, and its color will be black. So here we will consider, we will use a single sentinel nil, and for all the leaves of the red black tree with color nil. It's a leaf node that's also have color black, color of nil. Okay. Then the root of the parent is also a nil. Okay. Then it's also called a nility. Okay. So here we will discuss about the property of the red black tree. In a red black tree, we have a red node or a black node. We have a red node or a black node. Then root is always black. The red black tree always have a root is color black. Then every leaf nil is black. Every leaf in the last node will be nil and also have a black color. If a node is red, then both its children are black. If a node color is red, then always both children's color are black. Always kept in mind, if a node have a red, then they can't have the red color child. So they always have a black color child. Next thing, for each node, all paths from the node to descendant leaves contain the same number of black node. Through these, we will consider black height. Called BH, and if x node, then black height of x. Okay. Next thing, This is the concept of the red black tree. This node is the black, and these nodes are red. These nodes are red, and these nodes also have the value is nil. And color is black. Okay. And here we also have nil. Color is black. Same concept, nil. Nil. Then it's a balanced. Black, 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 black. Okay. So always remember, every internal node has two children. Every internal node, this is the internal node. This also have a two children. And even though the nil leaves are not usually shown, these leaves are not shown. Usually shown. Okay. Next, the height of the red black tree. So the height of the red black tree is the number of edges in the longest path to a leaf. Means we will consider the black height from the particular node, then we will consider without the considering of the particular node, and it goes toward the descendant conditions or towards the downside till nil node, means till leaf node. Then it will be consider, it will be checked the number of the black node. Then number of the black node is also called a black height of X. Okay, second thing, black height of node X. Then black height of X, number of black nodes including nil t. Then on the path from X to leaf, not counting X. Means suppose that this is a tree. This also have black, red, red, black, black, black. Then it's also nil. Nil. All nil have black color. Okay. So suppose that we will find out that this is the X. Then how much number of the black height? Yeah. What is the black height? Then nil color is also black, and this color means number of two black node. Then the height of this X is black height of X is, then here we can say that the property 5 black height is well defined. Okay. Next thing, height of a red black tree. How we will consider the height of the red black tree? Suppose that this is the tree and this is the root, and these color is also called black, black, red, black, black, red, red. Okay. And all left and right also have nil t. Okay. Then first of all, suppose that we want to find the black height of this. Then suppose this is the black and last nullity is the black, then 1 and 2, then black height is 2. Okay. We will, without the considering of the root node. Then suppose that how much the black height of x, then it's having only one black, this is called nil, then it's called the black height is 1. Okay. Next thing, this one, black height of 2, then this black and this black means 2 black, then the height is a black 2. This, and how much the black height of this? 30, black 3, BH is equals to 1, means black height is 1. Same here and same here. Okay. So always consider the black node except then root node or a particular node. We can say that suppose that I will take this 17 and after 17 how much the black height, then if we want to find out the black height of this 17, then except this 17, how many black node? Only 1. Then this is the black height is 1. Means suppose that आप जिस नोड से ब्लैक हाइट ले रहे हैं उस नोड की ब्लैक नहीं कंसीडर करना है, आप कंसीडर किसको करना है कि उस नोड को एक्सेप्ट देन वो नोड, then you will consider the number of black node. Then this is also called, number of black node is also called a black height of particular node. Okay. So here height of a node Hx tends to edges in a longest path to a leaf. Then black height of a node, black height of x is equals to black node on the path from x to leaf not containing x. How are they related? How are they related? This one, black height of x is equals to black height of x and 2 black height of x. Okay. So here the red black tree height is bound to a lemma, means the subtree rooted at any node x, then 2 black height of x minus 1 is an internal node. And second thing, the introduction on a height of x, base class, the height of x is a leaf, then black height of x is 0. Suppose that this is a root node x and also have the color black. Now what's the black height of this? Then here the formula is 2 की power black height of x minus 1. Then here the black height of x is 0. Then 2 की power 0 minus 1 is equals to 1 minus 1 equals to 0. Then black height of x is equals to 0. Second thing, induction steps. So here we will consider 2 types of internal node, means 2 की power bhx minus 1 plus 2 की power black height of x minus 1 or plus 1. If you will be calculated, then what will be the result? 2 की power bh x minus 1. This is the resultant. It's an induction theory. Okay. Next thing. So the operation of the arbitrary. This is the lemma that I already proved. Okay. Then this is the lemma. A red black tree with n internal nodes has height at most 2 log n plus 1. By the lemma, we will always know that the 2 to the power black height of x minus 1, then n is always greater than or equals to. Then since black height is greater than or equals to height by 2, so we have to consider the n is greater than or equals to 2 to the power height by 2 minus 1. So here we will put the value of black height is equals to h by 2. So always kept in mind, n is greater than or equals to 2 to the power black height minus 1. So here let black height is greater than or equals to height by 2. Okay. Then here we will consider put the value of this. Then n is greater than or equals to 2 to the power h by 2 minus 1. Okay. Then what is the height? Then if we will consider the taken log both side, then what will be the value? Then let taken log take log. So log n is greater than or equals to 2 to the power log 2 to the power h by 2 minus log 1. Then here we will consider this one, log n and log 1. Then log n plus 1, and here h by 2, log 2 base 2. Okay. Now what is the h? Log 2 base 2 is equals to 1. Then here h by 2 is equals to log n plus 1. Then what is the h? H is equals to 2 log n plus 1. This will be proved. This is the resultant. Okay. Got it? Next thing. Operation on the arbitrary. So here we will consider all operation can be performed in big O log n times. So the query of operation which don't modify the tree are performed in exactly the same way as they are in BST. Okay. Insertion and deletion are not straightforward. So here we will discuss about the two part rotation. Okay. So here rotation are two types, left rotation and right rotation. Okay. So suppose that this is the tree. This is the tree. Then what will be considered? X alpha then y, then beta, and then gamma. If we will consider the left rotate, suppose that it will be left rotate, then throw the x, because t comma x, x is a this, then we will hold up the x and pull in a left hand side, then y will be placed on the behalf of x, then x will be left side, then after x alpha is a left child, and this beta will be make a right child of x, and then gamma. Okay, then we develop this part. Okay, so again through the left we again consider the right rotation. What is the right rotation? We will hold the value on the t comma y, yani tree, and this y. Hold the y and pull on the direction of right side. Then we can say that it's a right rotate. After the right rotation, y is here and x will be the parent of y and alpha, and the right child of x will be make a left child of y, and this is the gamma. This concept is called the left rotation and right rotation. So this is the algorithm, left rotation and right rotation. Okay, so left rotate, suppose that y is the right of x, this is the x and this is the y, then right of x is y. Okay, right of x is y, then left of y is right of x, always kept in mind. Then left of y, then left of y, then जो भी left होगा y का वो क्या बन जाएगा, left of y will be make a right of x, जो भी y का जो left है वो x का right बन जाएगा, then जो y का left था वो x का right बन जाएगा. देखिए, then second, if left of y does not equals to nility, अगर जो भी left of y है, अगर y का ये जो left है does not equals to nility means nility नहीं है, then the x is a left of y of the parent, then जो भी हमारे पास जो x है, x का जो parent है वो left of y का parent बन जाएगा. ओके, सेकंड थिंग, जो parent of x है वो parent of y बन जाएगा. जो भी हमारे पास जो भी पेरेंट, जो x का पेरेंट में भी यहाँ पे x का जो ही पेरेंट है, जब x यहां से रोटेट होगा तो x यहां आ जाएगा, तो जो भी x का पेरेंट है वो क्या हो जाएगा, वही y का भी पेरेंट बन जाएगा. दिस वन. नेक्स्ट थिंग, इफ px इक्वल्स टू नील, अगर x का पेरेंट नील है, इफ x का मे बी x का कोई पेरेंट ही ना हो, मे बी अगर x का कोई पेरेंट नहीं होगा तो वहां पे y जाएगा, तो y ही क्या बन जाएगा, रूट बन जाएगा. अगर इसका पेरेंट ना हो तो यही क्या हो जाएगा, रूट हो जाएगा. दिस वन. else if then the left parent of x, जो भी left of parent, if else x is a left parent of x, अगर जो हमारा x है वो अपने पेरेंट का क्या है, लेफ्ट है, देन जो y है वो उसके लेफ्ट ऑफ पेरेंट ऑफ x का y बन जाएगा. यानी अगर ये अपने पेरेंट का लेफ्ट चाइल्ड है तो अब लेफ्ट चाइल्ड कौन बन जाएगा, y बन जाएगा. नेक्स्ट थिंग, अदरवाइज क्या हो जाएगा, ये राइट बन जाएगा. देन लेफ्ट ऑफ y, x इज अ लेफ्ट ऑफ y एंड y इज अ parent of x. Similar way. Okay, same we will consider on a similar way this algorithm. It's a left rotation. Similar way we will consider the right rotation. Okay, then after we will consider the next node. Then here, the pseudocode of the left rotate assume that right of x does not equals to nility and root of parent is a nil. Left rotation on x makes x the left child of y, left subtree of y into the right subtree of x. The pseudocode of the right rotate is symmetric exchange left and right everywhere. So time is big O1 for both left rotate and right rotate, since the constant number of the pointers are modified. So here we will consider the remainder red black tree properties again, because after this we will consider the insertion of the arbitrary. Okay, so the next part we will discuss in our part 2. Thank you very much.